Hello and welcome to my channel. In this video we are going to solve 1 mark questions from Quadratic Equations chapter which had appeared in CBSE Board Exam 2025 papers. Now in this video we are going to solve 6 questions and you will find each question along with its timestamp in the description box below. So let us start with the first one now. The quadratic equation whose roots are 7 and 1 over 7 is. So we can see 4 quadratic equations are given. So we need to find out which of these given equations represents the quadratic equation with the roots 7 and 1 over 7. So let us begin by writing the roots in the form of factors. So the factors are x minus 7 times x minus 1 over 7 equal to 0. Now if the roots are positive, so this is positive 7 and positive 1 over 7. Remember that the factors become x minus 7 and x minus 1 over 7. If one of the roots was negative, for example here it was given as negative 7, then in the factor form we would have written x plus 7. Now since both are positive roots, we are going to get negatives in the form of factors. Now once we have written the roots in the form of factors, let us look at the second factor and try to get a common denominator. So here x minus 1 over 7, this x becomes x over 1. Now we are going to get a common denominator by multiplying the numerator by 7 and the denominator also by 7. So we get x minus 7 times, now this becomes 7x minus 1 over a common denominator 7 is equal to 0. Now once we have got this becomes x minus 7 over 1. So the numerators will multiply together to give us x minus 7 times 7x minus 1. The whole thing gets divided by, now the denominators will get multiplied, giving us 1 times 7 as 7 equal to 0. Now in the next step, this denominator goes on the other side of equal to sign and it multiplies with 0, giving us x minus 7 times 7x minus 1 equal to 0. Now in the next step, we have expanded these brackets, that is x multiplies with 7x giving us 7x square, x multiplies with negative 1 giving us negative x, negative 7 multiplies with 7x giving us negative 49x, and negative 7 multiplies with negative 1 giving us positive 7 equal to 0. Now we can see that negative x and negative 49x, they both are like terms. So we can add them together giving us 7x square. Now minus 1x and minus 49x, they will add up together to give us minus 50x plus 7 equal to 0. So these two roots, when we combine them together, gives us the quadratic equation 7x square minus 50x plus 7 equal to 0. So here our quadratic equation is going to be option A. Now let us move on to the next question. If x over 12 minus 3 over x is equal to 0, then the values of x are. So let us rewrite this given equation. Now here we need to find out the values of x. For that let us use the cross multiplication method. So here x multiplies with x giving us x square minus 3 multiplies with 12 giving us 36 over, now the denominators will multiply together giving us 12x equal to 0. Now let us take this denominator on the other side of equal to sign so that 12x multiplies with 0 giving us x square minus 36 equal to 0. This denominator multiplies with 0 giving the right hand side as 0. Now in the next step we are going to take negative 36 on the right hand side. So we get x square is equal to 36. Now taking square on the other side of equal to sign, we get the value of x as plus or minus square root of 36 and square root of 36 is 6. So we get the value of x as plus or minus 6. So here our answer is going to be option A. The value of x is going to be plus or minus 6. Let us move on to the next question. The value of a for which ax square plus x plus a is equal to 0 has equal and positive roots is. Now this question is a combination of polynomials and quadratic equations chapter. So it's been mentioned here that we need to find out the value of a given the fact that the roots are equal and positive. So we need to use two conditions over here. The first condition being the discriminant b square minus 4ac should be equal to 0 because the roots are given as equal roots. So once we have written the first condition, let us write down the general form of quadratic equation which is given as ax square plus bx plus c equal to 0. Now we are going to compare this general form with the equation given in the question. So here a will be equal to a because both are the coefficients of x square. B will be equal to 1 because both are coefficients of x. And c is equal to a because both are constants. Now once we have got the values of a, b and c, we are going to plug in these values in the discriminant formula. So here we get b square becomes 1 square minus 4 times a is a itself times c is a equal to 0. Now 1 square gives us 1 minus 4 times a becomes a square equal to 0. So in the next step we are going to take minus 4a square on the right hand side so that it becomes plus 4a square equal to 1. So a square will be equal to, now taking 4 on the other side of equal to sign, we get 1 over 4. Now taking square on the other side of equal to sign, we get the value of a as plus or minus square root of 1 over 4. Now square root of 1 is 1 itself and square root of 4 is 2. So the value of a we get here is plus or minus 1 over 2. Now if we look at the options, we have positive 1 over 2 as well as negative 1 over 2. So which of the two options should we choose? So for these kind of questions, we have to make use of the second condition, which is for positive roots, because in the question they have given equal and positive roots. So this is the second condition. The sum of zeros, that is minus b over a, and product of zeros, that is c over a, must be positive. So this is where the polynomials chapter comes into picture. So we have to find out the sum of zeros and product of zeros for the given quadratic equation. So here sum of zeros is given as alpha plus beta is equal to minus b over a. So here we had the value of b as 1 and the value of a as a. So we are going to plug in its value over here. So alpha plus beta will be equal to minus from the formula, the value of b is 1 over the value of a is a. So sum of zeros we got as minus 1 over a. Now product of zeros is alpha times beta equal to c over a. So alpha times beta becomes the value of c we have here is a and the value of a is a. So product of zeros we get here is alpha beta equal to a over a, giving alpha beta as positive 1. So product of zeros we have got it as a positive value, but let us check for sum of zeros, because sum of zeros also we should get positive. So in place of a, we are going to plug in the value 1 by 1 which we have got over here, starting with a is equal to positive 1 over 2. So here we have taken the value of a as positive 1 over 2 and we have plugged it in the sum of zeros we have got, that is alpha plus beta is equal to 1 over a. In place of a we have written positive 1 over 2. Now here we get negative 1 stays the same, the division becomes multiplication and the fraction 1 over 2 flips, giving us 2 over 1. So here alpha plus beta becomes negative 1 times 2, giving us negative 2 over 1 or negative 2. So a is equal to 1 over 2 gave us negative sum of zeros. So now let us check for a is equal to minus 1 over 2. So a is equal to minus 1 over 2, alpha plus beta is equal to minus 1 over minus 1 over 2. Now here this numerator negative 1 stays the same, the division becomes multiplication and minus 1 over 2, this fraction flips, giving us minus 2 over 1. Now minus 1 times minus 2 gives us plus 2 over 1 or plus 2. So here we can see that if we take a is equal to minus 1 over 2, we get a positive sum of zeros, that is positive 2. So here our answer has to be a is equal to minus 1 over 2 because it satisfies both the conditions, especially the second condition where the sum of zeros and product of zeros must be positive. So here our answer is going to be option D. The value of a must be minus 1 over 2. Now let us move on to the next question. Which of the following equations is a quadratic equation? So we can see that 4 options are given. So we need to find out which of the given equations is quadratic, which means we have to see in which equation the highest power of x is going to be 2. So to solve this question, we need some algebraic identities. So let me list it out over here. So these are the identities we'll be using over here. Now we have considered the first option, that is x square plus 1 is equal to x minus 1 the whole square. Now we have kept the left hand side same as it is, equal to. Now to expand the right hand side, we have made use of the first identity, that is a minus b the whole square. So using this identity, we have expanded this bracket as x square minus 2 times x times 1 plus 1 square Now simplifying this, we get x square plus 1 is equal to x square minus 2x plus 1 square gives us 1. Now we can see that x square cancels from both the sides of the equal to sign, simplifying the equation as 1 is equal to minus 2x plus 1. Now since we are looking for a degree of x which is going to be 2, but here the highest degree of x is 1, so the first option is not going to be our answer. Now let us look at the second option. So x plus square root of x the whole square is equal to 2x root x. Now to expand the left hand side, we have made use of the second identity. So x square plus 2 times x times square root of x plus square root of x the whole square is equal to 2x root x. Now let us simplify the left hand side. So we get x square plus 2x root x plus, now square of the square root disappears, giving us x is equal to 2x root x. Now we can see that 2x root x cancels from both the sides of the equal to sign, simplifying this equation as x square plus x equal to 0. Now since here highest degree or highest power of x is 2, this is going to be our correct option, that is option B, which represents the quadratic equation. Now let us check out option C and D as well, if they represent the quadratic equation. You can stop over here once you have got the answer. I'm just going to show here how we are going to expand this and check whether they are going to be quadratic or not. So here we have considered the third option, that is option C. X cube plus 3x square is equal to x plus 1 the whole cube. Now here we have kept the left hand side same, and to expand the right hand side we have made use of the third identity, that is a plus b the whole cube. So this expands as x cube plus 1 cube plus 3 times x square times 1 plus 3x times 1 square, that is by using this identity. Now let us simplify this. We get it as x cube plus 3x square is equal to x cube plus 1 cube is 1 itself plus 3x square plus 3x. Now here we can see that x cube cancels from both the sides of the equal to sign as well as the 3x square. So here this equation simplifies as 0 is equal to 1 plus 3x. We can see here the highest power of x is 1. So the option C is also the wrong option. Now finally let us check for option D as well. So here we have written option D, x plus 1 times x minus 1 is equal to x plus 1 the whole square. Now for the left hand side we are going to make use of the last identity, that is a plus b times a minus b is equal to a square minus b square. So here we get x square minus 1 square is equal to, now x plus 1 the whole square can be expanded as x square plus 2 times x times 1 plus 1 square. Now simplifying this equation we get x square minus 1 square is 1 is equal to x square plus 2x plus 1. Now here also we can see that x square terms gets cancelled, giving us minus 1 is equal to 2x plus 1. So the highest power of x here is 1. So the option D is also not going to be the correct answer. So the only equation which represents the quadratic equation is option D. Now let us move on to the next question. If x square plus bx plus b is equal to 0 has two real and distinct roots, then the value of b can be. So here they have mentioned that this quadratic equation given has two real and distinct roots. So let us write down the condition for the discriminant of two real and distinct roots. So the condition is b square minus 4ac should be greater than 0. So once we have written the condition, next we have written the general form of quadratic equation, which is ax square plus bx plus c equal to 0. Now comparing the general form with the given equation, we can say that the value of a is equal to 1 because both are the coefficients of x square. The value of b is equal to b because both are coefficients of x. And the value of c is equal to b because both are constants. Now once we have got the value of a, b and c, we are going to plug it in this condition. So b square becomes b square because the value of b is b itself minus 4 times the value of a is 1 times the value of c is b should be greater than 0. Now simplifying the left hand side we get b square minus 4 times 1 is 4 and 4 times b is 4b is greater than 0. Now in the next step we have factorized the left hand side because we can see that b is a common factor. So we have taken it out and inside the bracket remains b minus 4 greater than 0. Now we have to see which of the values of b satisfies the condition we have got over here. So let us start by taking the value of b as 0. So if you put the value of b as 0 here, so we get 0 times, now 0 minus 4. Let us see if it is going to be greater than 0. So 0 multiplied with anything is 0 itself. So we cannot write 0 is greater than 0 because it doesn't make sense. So here our option A is going to be incorrect. Now let us check what happens if we take the value of b as 4. So here we are going to write 4 times, now 4 minus 4. Now let us see if it is going to be greater than 0. So we get here 4 times, now 4 minus 4 is 0 and 4 times 0 is 0 itself. So we cannot again write 0 is greater than 0. So our option B is also incorrect. The value of B cannot be 4. Now let us check for B is equal to 3. So let us take B is equal to 3 now. So 3 times 3 minus 4. So here we get 3 times. Now 3 minus 4 is minus 1. So 3 times minus 1 is minus 3. And minus 3 is lesser than 0. It is not greater than 0. So option C is also incorrect. So the correct answer has to be option D, but let us confirm. So here we are going to take negative 3 multiplies with negative 3 and negative 4. Now here negative 3 multiplies with, now minus 3 minus 4, they will add up together to give us minus 7. And minus 3 times minus 7 gives us positive 21, which is greater than 0. Which means our option D is the correct answer. The value of B can be negative 3 because it satisfies the given condition. Now let us move on to the next question. Which of the following quadratic equations has real and equal roots? So here we need to find out which of the given options has real and two equal roots. So let us start with option A. Now in option A, x plus 1 the whole square is being expanded by using the identity a plus b the whole square. So this expands as x square plus 2 times x times 1 plus 1 square is equal to, now the right hand side stays the same, that is 2x plus 1. Now simplifying the left hand side, we get x square plus 2 times x times 1 gives us 2x plus 1 square is 1 is equal to 2x plus 1. Now here we can see that 2x can be cancelled from both the sides of the equal to sign, that is they will get subtracted, and plus 1 also gets cancelled. So we are left with x square is equal to 0. Now square, when you take on the other side of equal to sign, it becomes plus or minus square root of 0. So square root of 0 is 0 itself. Now since we have the highest power of x as 2, we need to have two roots over here. So the solution is going to be x equal to 0 and x equal to 0. And 0 is a real root. And the roots we can see they both are equal. They both are same. So here our answer has to be option A. That is x plus 1 the whole square is equal to 2x plus 1. Now let us confirm with rest of the options as well. So let us check option B now. So here for option B, we can see that x is a common factor in both the terms. So we have taken x as a common factor and inside the bracket remains x plus 1 equal to 0. Now here we have two factors of x, that is x equal to 0 and x plus 1 equal to 0. So the first value of x is 0 over here. And the second value of x is going to be, when we take the plus 1 on the other side of equal to sign, the x value becomes negative 1. Now here we can see that these are two real roots, but they are not equal. They are not same. So option B is incorrect. So this is the way you are going to find it. Now let us move on to option C. Now x square minus 4 can be written as x square minus 2 square equal to 0. So this represents the algebraic identity a square minus b square. So it will be expanded as a minus b times a plus b. So here x square minus 2 square is written as x minus 2 times x plus 2 equal to 0. Now here we have two factors. So we are going to equate them independently to 0. So x minus 2 equal to 0 and x plus 2 equal to 0. Now taking minus 2 on the other side of equal to sign, we get the value of x as 2. And here taking plus 2 on the other side of equal to sign, we get the value of x as minus 2. So here you can see we have got two real roots, but again they are not equal. They are not same. So the option C is also incorrect. Now if we look at option D, it is not factorizable because here the product is 1 and the sum is also 1. So there are no factors when which added together gives us plus 1. So if you use the quadratic formula also, you'll be ending up with non-real roots. So the option D is also wrong. So you don't have to check for all the options if you have got the correct answer. Here I have just elaborated it so that you know how to solve these kind of questions. And this was the last question in Quadratic Equations multiple choice questions. So if I have left out any of the questions from CBSE board exam papers, then I will be including in the playlist. And I hope you understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.